Division of segments and angles, Level 3. In this video, we will go over more basic examples involving division of segments. Let's take a look at the first example. Name the congruent segments. Point O is the midpoint of segment CD. In this problem, we are asked to determine which segments are congruent given that point O is the midpoint of segment CD. Recall that a midpoint splits a segment into two congruent segments. Since point O is the midpoint of segment CD, it will split it into two congruent segments. We can illustrate this by drawing a single tick mark for segment DO and segment OC. In this case, segment DO is congruent to segment OC. And this is our final answer. Alright, let's try the next example. Name the congruent segments. Segment SW bisects segment XV. In this problem, we are also asked to determine which segments are congruent given that segment SW bisects segment XV. Since segment SW bisects segment XV, we know that segment XV will be split into two congruent segments. We can illustrate this in the diagram by drawing a single tick mark for segment XW and segment WV. In this case, segment XW is congruent to segment WV. And this is our final answer. Alright, let's take a look at the next example. Point B and point C trisect segment AD. Find the coordinates of point B and point C and the measurement of segment AC. In this problem, we are provided with a diagram of a line segment with 4 points. We are given that point B and point C trisect segment AD. This means that these 2 points will split line segment AD into 3 congruent segments. In this case, line segment AB will be congruent to line segment BC, which is congruent to line segment CD. So we can draw a single tick mark for each of these line segments. Since all 3 line segments are congruent, all we need to know now is the length of segment AD. We can determine this length by using the coordinates of point A and point D. In this case, the length of segment AD is equal to the absolute difference between the coordinates of point D and point A, which is equal to 21. Now that we know the length of segment AD, we go ahead and divide this length by 3 to obtain the length of each congruent line segment. In this case, each line segment will have a length of 7. With this length, we can now determine the coordinate of point B and point C. The coordinate of point B will be equal to -5 plus 7, which is equal to 2. And the coordinate of point C will be equal to 2 plus 7, which is equal to 9. Finally, we can determine the measurement of segment AC by finding the absolute difference between the coordinates of point C and point A, which simplifies to 14. And this is our final answer. Alright, let's move along to the next example. In the diagram, line segment HL and line KT intersect at the midpoint of line segment HL. Classify each statement as true or false. Segment LM is congruent to segment MH. In this problem, we are provided with a diagram, along with some geometric relations. We are asked to determine if the following statement is true or false. Before we attempt to answer this question, let's mark the diagram with the given geometric relations. We are given that line segment HL and line KT intersect at the midpoint of line segment HL. This means that line segment HM and line segment ML are congruent, since a midpoint splits a line segment into 2 congruent line segments. So let's go ahead and draw a single tick mark for each line segment. Now let's determine if the statement is true or false. The statement reads segment LM is congruent to segment MH. Looking at the diagram, we see that segment HM and segment LM are indeed congruent. So we can conclude that this statement is true. Let's take a look at the next statement. Segment MT bisects segment LH. Notice that the endpoints of segment MT are collinear with line KT. Since we are given that line KT intersects at the midpoint of segment HL, we know that line KT is a bisector of segment HL. The endpoints of segment MT are collinear with line KT. We can conclude that segment MT is also a bisector of segment HL. So this is a true statement. Alright, let's move along to the next example. Name the following: the midpoint of segment BF. In this problem, we are provided with a diagram of a number line, along with some points located at a particular coordinate. We are asked to determine the midpoint of segment BF. Let's first determine where segment BF is located in the number line. We know that point B is located at -2, and point F is located at 2. In order to determine the midpoint, we need to know the length of this line segment. We can determine the length by taking the absolute difference of the point's coordinates. In this case, the length of segment BF is equal to 4. We know that the midpoint will be located at a distance that is half this length, relative to either endpoint of line segment BF. If we start at point B and move 2 units to the right, we end up at point D with a coordinate of 0. Notice that point D is 2 units away from both point B and point F, so we can conclude that point D is the midpoint of segment BF. Okay, let's take a look at the next example. Draw segment CD and segment RS so that the conditions are satisfied. Segment CD and segment RS intersect, but neither segment bisects the other. In this problem, we are asked to draw a diagram so that the given conditions are satisfied. The condition states that segment CD and segment RS intersect, but neither segment bisects the other. Let's start by drawing segment CD. Next, we need to draw segment RS intersecting segment CD, making sure that this intersection does not bisect either of these 2 line segments. We can show this by not drawing any tick marks in the diagram. So the following diagram is one of many possible drawings that satisfy the conditions. Let's take a look at the next condition. Segment CD and segment RS bisect each other. Similar to the previous problem, we can illustrate these conditions by drawing 2 line segments that intersect very close to each other's midpoint as follows. Then, we need to draw tick marks for each line segment to show that each line segment is bisected. So we draw single tick marks for one line segment and double tick marks for the other line segment, as follows. So this diagram is one of many possible drawings that satisfy the conditions. Let's take a look at the final example. Segment CD bisects segment RS, but segment RS does not bisect segment CD. Just like the previous 2 problems, let's draw 2 line segments, making sure that segment CD intersects segment RS around its midpoint, as follows. We also need to make sure that the midpoint of segment RS is not the midpoint of segment CD. We can illustrate this by drawing single tick marks on segment RS, as follows, making sure we do not add any tick marks on segment CD. So this diagram is one of many possible drawings that satisfy the conditions. Alright, in our next video, we will go over more challenging examples involving midpoints, bisectors, and trisectors.